Hello everyone, let's now recap mole concept. First of all, what is mole? So mole is just this really big number, which is 6 times 10 to the power of 23. This is a big number. It's just a number like any other to describe the quantity of very small substances like atoms, molecules, ions, or even electrons. So it's just a number. So for example, when I say 1 mole of calcium, what does that mean? It means that I have 6 times 10 to the power of 23 calcium atoms. Now, mole is to describe matter, right? Very small matter. So when it comes to matter, when it comes to mole concept, okay, we always calculate the mass, the amount of mass that matter has. Or if it's a gas, we can also calculate its volume. Right? So how do I do that? When I use mole. Because to calculate that, I must know how many or what is the quantity of the substance. So we use the unit mole. So mole is basically just a unit of counting atoms, molecules, ion, and electrons. So the periodic table is really important because why? If you refer to the key, they tell you the relative atomic mass. It is sometimes used as AR, or if it's a molecule or a compound, it's used, the symbol is MR. Right, so this is the mass. So these numbers below, what does that mean? It means that 1 mole of hydrogen atoms has a mass of 1 gram. It means that 1 mole of helium atoms have a mass of 4 grams. If I look at gold, 197 is the relative atomic mass. What does that mean? It means that 1 mole of gold has 197 grams. Right, so why is this important? Because this is important because I can calculate the mass of any quantity of substance. So for example, if I have 1 mole of hydrogen atoms that gives me 1 grams, it means that 2 moles is just the double. This is 2 grams. Right, that is one. Now the next one is the number of mole of any gas is also given in the periodic table, which is 24 dm cubed. So what does that mean? Any gas. So for example, 1 mole of oxygen has a volume of 24 dm cubed. What is 1 dm cubed? 1 dm cubed is 1000 cm cubed. That means if I have 12 dm cubed of oxygen, that means that the number of moles must be half, which is 0.5 mole. So remember, from the periodic table, I can calculate the mass of anything. And if it is a gas, I can calculate the volume of any amount of moles. But again, this is only for gases. So let's look at round 9. So 3 moles of hydrochloric acid was reacted with excess sodium carbonate. Question A, find the number of moles of water formed. So here I have HCl, here I have water. So what do? I just write HCl is to H2O. Now notice that in the first line, I do not write any numbers, just the substance, right? Just the substance. So what is the ratio? The ratio, I use the numbers that I use to balance this chemical equation. So this is 2:1. Since HCl is 3 moles, so 2 units is 3 moles, so 1 unit will be 1.5 moles. Done. So if the question is kind to you, they will just like you to find moles and the answer to be in moles as well. Right, so let's look at question B. In question B, we are looking for volume of carbon dioxide using the amount of hydrochloric acid. So HCl is to carbon dioxide. This is 2:1. So again, the numbers that is used to balance the equation comes in the second line of the ratio. So let's calculate. So we know that we can calculate the volume of anything, but I must find out what is the mole first. So since I have 3 moles of hydrochloric acid, that means I must have 1.5 mole of carbon dioxide. Alright, so when you're doing calculations like this, keep your ratio in the center, and then the right or the left, extra calculations that is needed. So always keep your ratio calculations in the center. Alright, so now I have 1.5 moles of carbon dioxide. Can I stop there? No, because I need to find the volume of carbon dioxide. And therefore, since I know that 1 mole of any gas gives me a volume of 24 dm cubed, if I have 1.5 moles of carbon dioxide, this is 36 dm cubed. And that is your answer. Alright, so this is very straightforward, very simple. Now let's look at round 2. 20 grams of HCl was reacted with excess sodium carbonate. Now, whenever they give you grams, you always must convert to mole first. Okay, tell yourself, mass, grams is useless. In mole concept questions, you always need to calculate in moles, so I need to convert grams into moles. So once again, you always start the ratio in the middle. So HCl and water, right? So HCl is to water. This is 2:1. So this is 20 grams. I cannot put 20 grams here, right? So what do? I need to convert my HCl first. So I have mass. I can calculate 1 mole of HCl. This is 36.5 grams. But I only have 20 grams. So 20 divided by 36.5. Okay, so remember your answers. So your working must be in 3 sig fig. Not round them up to... the significant figures in your working must be in 4 sig fig, because your final answer will be in 3 sig fig. Right, so 20 grams of HCl is actually 0.5479. So I just plug this number in now. So remember, whatever calculations in the middle must be always in moles. And therefore, I divide this into 2. So this is 0.27397 moles. Right, and therefore my answer will be 3 sig fig 0.274 moles. Done. So here I have to make an extra conversion. So like for the previous one, everything is in moles. Very nice. But sometimes the question gives you something extra to work on. So that something extra is to just convert the gram into mole. Right, so let's look at B. Hydrochloric acid and carbon dioxide. So HCl is to carbon dioxide, 2:1. Just now, previously we calculated 20 grams as 0.5479. So this is 0.5479 moles. And therefore, carbon dioxide will be the number of moles of carbon dioxide will be 0.27397 moles. Can I stop there? No, because they want me to calculate in mass. So here is my extra working column on the right hand side. So 1 mole of carbon dioxide. So if I use my periodic table, I know that the relative atomic mass of carbon is 12, oxygen is 16. So this will give me 44 grams. And what does my question want? My question wants 0.2727397 moles. And I just take this times 44 grams. And that will be 12.055 grams. So to 3 sig fig, it will be 12.1 gram. And that is your answer. Okay, so it's really converting back and forth. Remember that in the middle is only for ratio. So let's look at round 3. What does round 3 entails? It has to do with problems containing concentration. So quickly let's look at what is concentration first. So what you see here is a substance called copper 2 chloride. Now in copper 2 chloride solid, right? So what I have are particles, right? Solid particles. So this is in the first few chapters. So solids are packed together and they only vibrate in fixed position. So what does that mean? That means that if I have another substance like that and it's supposed to react with copper 2 chloride, there will be no reaction. Why? Because the ions are in fixed positions. So what needs to be done for this to be able to move about, for copper 2 chloride ions to move about? Okay, to do that, you need to dissolve. So once you dissolve this copper 2 chloride, let's say in a cup or in a beaker, once you dissolve, the ions become mobile. Once the ions become mobile, then there can be a reaction. So what do I dissolve the copper 2 chloride? I dissolve them in water. Right, so something like that. Okay, so beautiful color change. And then here you see the solid dissolving, and then the ions are now free to move and to react. So concentration, there is a standard. What is the standard? The standard is always how many per 1 dm cube of water. Right, so 1 dm cube once again is 1000 cm cube. So I can have two different units. I can have something in mole per 1 dm cube, or I can also have grams per dm cube. So what does that mean? Let's see if I have 2 moles per 1 dm cube. Let's say this is HCl. So it means that, let's say I have a solution. What is the volume here? 1000 cm cube. And inside this 1000 cm cube, I have 2 moles of HCl that is dissolved. So let's say if I have 2 moles that is dissolved in 1 dm cube, if I do not use the whole 1000 cm cube, I am only using 10 cm cube. I am only using 10 cm cube. So how many moles are there in that 10 cm cube I've extracted from that 1000 cm cube? Alright, so that will be, so 10 divided by 1000, then the answer I times 2 moles, and that gives me my answer, and that will be 0.02 moles. Right? So sometimes, not sometimes, this is always the case. Right, so this is what it means. So let's say if I have 40 grams per dm cube, that means I have 40 grams of, let's say, X dissolved in 1000 cm cube. Let's say I am only using 500 cm cube. So in that 500 cm cube, how many grams of X is that? It's just 20 grams of X. Right? In some cases, they give you, oh, I have this sample solution of W, for example. What is W? W is 1.5 moles. It's dissolved in 250 cm cube. And then they tell you, okay, find concentration. So, fret not, because I know that concentration is always per 1 dm cube. So I just need to find 1000 cm cube. And, so 1000, so you go one round, like what we have mentioned in class, 1000 divided by 250 times, and then this is my equal sign. So this will be 6 moles. So whenever the question asks you for concentration, you cannot leave your answer like this. You must always write out in proper unit, which is 6 moles per dm cube. Alright, so this is concentration. So again, in a very nice situation or scenario, you only need to deal with ratio. But of course, this is O levels. They will probably give you an extra step to do also. Sometimes they will require you to convert from mass to mole. Then you can use the ratio. Sometimes volume of gas. Then you convert to mole. Then you can use ratio. Sometimes it's even concentration. Then you find mole. Then use the ratio. So it depends on the problem. So let's look at the first example. Right. So let's say 30 cm cube of 1.5 mole per dm cube was reacted with excess sodium carbonate. So the equation is the same equation as the previous ones. It's just that the context of the question has changed. So this is 1.5 mole per dm cube. Am I using 1000 cm cube? I'm not. I'm only using 30 cm cube. Okay, again, same thing like in the previous question. What are the substances that is in question? Hydrochloric acid and water. So again, we always start with the ratio in the center. This is 2:1. So can I use HCl straight away? I can't, right? Because I do not have the moles, the number of moles of HCl, but I can find out, isn't it? So if this is 1.5 mole of HCl dissolved in 1000 cm cube, I'm only using 30 cm cube. So divide, so go one round, equal. And that will give me, 0.045 moles. That is in 30 cm cube of this sample of hydrochloric acid. So this is 0.045 moles, and therefore the number of moles of water will give me 0.0225 moles. And that is your answer. Okay, next question. Same question. Oh, let's look at question B. So question B now states that you need to find the volume of carbon dioxide. So HCl is to CO2 is 1. So here we have calculated that 30 cm cube of 1.5 mole of dm cube of hydrochloric acid contains 0.045 moles. So I just plug the numbers in. And we cannot stop here because the question wants volume. So I just write 1 mole of CO2 gives me 24 dm cube. So now I have 0.0225 moles, and using my calculator, and this will give me 0.54 dm cube. And you are done. So again, keep the ratio in the center and all the other extra calculations at the side. Okay, so let's look at this type of question. This type of question is quite common. I have 30 cm cube again of hydrochloric acid that is reacted with 20 cm cube of sodium carbonate. Now, they want you to find the concentration. So, what is concentration? You know, sometimes you are stuck. You just write whatever units that comes to your mind here. Okay, so they want you to find the concentration, right? So what have they given you? They have given me the volume. So, they have given me the volume in cm cube. Right, so I know that before I calculate the mole per dm cube, I need to find how many moles was dissolved in 20 cm cube first. So again, always come back to mole. So HCl is to Ne2CO3. Ratio is 2:1. So previously this was 0.045 moles. and this is 0.0225 moles as well. Right, so here I already have found the number of moles of sodium carbonate that is used in this reaction. So this is 0.0225 moles of Na2 that was dissolved or that was found or present in 20 cm cube of solution. So what do I do now? I just need to find concentration. I have volume of water. I have the number of moles. So I just need to find 1000 cm cube. So this will be 1.125 moles. Again, I cannot leave my answer like this. I just need to find... I just need to write it up properly in the proper units. And that's it. Next, the last round is what we covered this year. This is the last part. It's about limiting reagents. Alright, so let's say in an ideal situation here, I have 50 dm cube of carbon monoxide is reacted with excess oxygen. Calculate the amount of carbon dioxide that is formed. So carbon monoxide, carbon dioxide. So I need to find the amount of carbon dioxide, and to do that, I use the quantity that's given for carbon monoxide. Now, just now we have been using ratio for moles, right? I also want to remind you that I can also use ratio directly when it comes to volume. But this is volume of gases. Okay, and that means if I have used 50 dm cube of carbon dioxide, I can calculate it directly. This is 25 dm cube. So my answer is 25 dm cube, but I made a mistake. This is 2, I apologize. Therefore, this is 50 dm cube. Okay, so one more time. Once I have volume of gases, and if I need to find out the quantity of another substance, which is also a gas, I can straight away use the volume as it is. Right, so this is 50 is to 50. Now, when do I look out for limiting reagents? When both quantities of the reactant is given. So steps are slightly different, so I just write carbon monoxide is to oxygen. Remember, I always start with the ratio first no matter what. So what does the question give you? So my next column will be have. What do I have? I have 50 dm cube of carbon monoxide and 30 dm cube of oxygen. Then my next line will be if. If I use 50 dm cube of carbon monoxide, I only need 25 dm cube of oxygen. And what does this mean? Do I have 25 dm cube of oxygen if I use 50 dm cube of carbon monoxide? Yes, I do. Right? So what does that mean? That means that my oxygen is in excess and my carbon monoxide is the limiting reagent. Now, why is this important? This is important because to find out what is the limiting reagent, because the limiting reagent will determine amount of product. Right, so I know that carbon monoxide is my limiting reagent. So let's find out the number of amount of the volume of carbon dioxide that is formed. So carbon monoxide is to carbon dioxide is to 2 equal proportions. So if this is 50 dm cube, this must also be 50 dm cube. So calculate the volume of gas formed at the end of the reaction. So at the end of the reaction, I have 50 dm cube of product, which is my carbon dioxide. Now, if you look back at your working, I have oxygen that is in excess, isn't it? Right, so if I've used all 25 dm cube of oxygen, what is the remaining volume of oxygen that is left? This is 5 dm cube. Right, that is left. And my answer is not 50 dm cube of product, because the volume of gas will be made up of two things. The first one, volume of product, and the volume of remaining reagent that is in excess. So at the end of this reactant, at the end of this experiment, I will have carbon dioxide, and I will also have remaining excess reactant, and my excess reactant is oxygen, and this is 5 dm cube, and therefore your answer will be 50 dm cube plus 5 dm cube, which is 55 dm cube. Actually, this is an O-level question. This question is very similar to O-level questions on limiting reagents that always appear in MCQ. Right, that will be all. Thank you.